When we begin to work with exponents and radicals, we have to learn how to express a non-prime number as its simplest base to an exponent. And we can do this with a factor tree. I'm going to do an example of the number 64. 64 can be reached at when you multiply 8 times 8. But 8 is not prime, so we have to continue factoring. 8 is equal to 4 times 2. So both 8's can be broken down into 4 times 2. The 2's are prime, but the 4's are not, so we're not finished. This 4 is 2 times 2. I carry down this times 2. This 4 is also 2 times 2. And I carry down this 2. We end up with a line of 2's at the bottom with this number. And if we count them up, we see there are 6 of them. That means 64 can be written as 2 to the power of 6. But what if we don't choose 8 and 8 as our factors in the first step? What if we decide that we're going to choose 2 times 32? Well, this will still work. But the 2 is prime, it's just going to be carried down. And the 32 can be broken into any two factors of 32 that we want. We can use 4 times 8. Since the 4 and the 8 both have factors, we have to continue. This 2 is carried down. This 4 turns into 2 times 2. We have found prime factors of that part. And the 8 can turn into another 4 times 2. Still not finished. We have one 4 left to deal with. This 2 gets carried down. This 2 gets carried down. This 2 gets carried down. This 4 turns into 2 times 2, and this 2 gets carried down. We end up with the same result. We have 6 2's lined up along the bottom, so expressed as its simplest base to an exponent, 64 is still 2 to the power of 6. It doesn't matter which numbers we use when we start. We will always end up with the same result. Let's look at a couple of different examples. 81 can be expressed as 9 times 9. And 9 is not prime. 9 has 3 times 3 as factors. So I take this 9 and I express it as 3 times 3, and I do the same with this 9 over here. I'm finished because all of these 3's are prime. We have 4 of them, so 81 can be expressed as 3 to the power of 4. How about 72? We can express 72 as 8 times 9. And again, the 9 can be expressed as 3 times 3, but the 8 breaks down into 4 times 2. And we're not finished because of this 4. It breaks down into 2 times 2. This 2 gets carried down. The 3 gets carried down. And this 3 gets carried down. This time we have a mixture of 2's and 3's, but this is no problem. We can express this as 2 times 2 times 2. There are 3 of them, so we have 2 cubed. And 3 times 3, there are 2 of those, we have 3 squared. 2 cubed, 3 squared is a valid way of expressing the number 72. When I work with exponents, I'm able to remember that 64 is 2 to the power of 6. And 81 is 3 to the power of 4. Even the number 72, if I think about it a bit, I can do in my head the factoring and realize that it is equal to 2 cubed, 3 squared. But eventually we get to big enough numbers, complicated enough numbers, that we really need to use this factor tree method or another equivalent method to break it down to its simplest bases with exponents. Let's do a couple of examples like that. 675 is equal to 5 times 135. As soon as I see that it ends with a 5, I know it has to be a multiple of 5. So I can play around with my calculator if I want, and I can find that these two numbers multiply to give it. And then it becomes a lot easier because 135 is a much smaller, simpler number to deal with than 675. the 5 will carry down, and 135 is also a multiple of 5. It ends with 5. It is 5 times 27. Now we're down to 27, which is a more familiar number. The 5 carries, this 5 carries. 27 can be broken down into 9 times 3. And now the 9 is the only non-prime number left. So we have 5 times 5 times 3 times 3 times 3. 675 expressed as its simplest basis with exponents is 5 squared, 3 cubed. Let's try 968. This one is even more confusing, but we can see that it's an even number. So it has to have 2 as a factor. We'll just start off easy by breaking it down into 2 times 484. Again, 484 is not that nice to look at, but it's an even number. So we can break it down into 2 times 242. 242 is still even, so it can be broken down into 2 times 121. And now I get to a number that I recognize from my times tables. 121 is 11 squared. So this ends up being 2 times 2 times 2 times 11 times 11. 968 can be expressed as 2 cubed 11 squared. Even very complicated numbers can be broken down in this way.